Howdy folks, I'm Keith Bowen, this is Hard Rock University. Today we're going to go into a little more depth of the bob mill. We have one of our viewers who's working on a mill and he's got a few questions, so I thought I could answer him this way and the most completely possible. So anyhow, this is the bob mill. Stands for Bow and Ore Buster, name Eva came up with. And what it is essentially a big heavy-duty blower that when you put the rock in it, it beats it into a powder and blows it up to the milling process. So you have a housing and you have an exhaust port here. Okay, that goes all the way up there. It's about an 8-foot rise.
Now I have a question. Is there a particular reason you decided to put the port in that position instead of on the sides or on the bottom, somewhere else?
Absolutely.
Or directly on top right here?
Yes. First of all, it can be in any one of those 4 positions if you just undo these bolts here. Take it off, rotate it around, and bolt it somewhere else. So it can be pointing this way, that way, or that way. It's pointing up right now. First of all, we're trying to elevate stuff, but also as this is designed right, it's configured right now to operate dry. And so as the pieces of rock start going up that way, if they're too big, they will fall back down and get hit again. So the purpose of this is a classification column. When it comes out of here, the vast majority of stuff is pretty small. Now here's something in here. This little deflector takes the bigger rocks and kicks them out this way. Okay? Otherwise they can be thrown up there pretty violently and go quite a ways. Go pretty easily. Now, as you might imagine, when you're beating hard rock up, steel is pretty difficult to deal with that. It doesn't last too well. You can see here these little divots. This is where the wear plates wore through without me noticing it, wore through the edge, and it started eating out the rotor. Now, if you were to put this in service without some kind of wear plates to provide extra protection, this rotor would be useless in about a day. It would be completely worn out.
So these are the wear plates.
Correct.
And that is where they go on the rotor paddle or the rotor blade.
Yeah, call it a paddle, just fine. Yeah. And so when you wear stuff out, you can take it off, and in this case, these beads right here are something called hard facing. It's a lot harder than normal steel. So you can take normal steel or hardened steel and create a much more durable surface. And the other thing is you can redo this time and time again so that these wear plates do not wear out very fast at all. They just wear down, you pull them off, you redo the hard facing, and you slap them back on.
Now I had another question. Is there a particular reason why the back of the bob is not the same shape as the chamber? Or is that just aesthetics?
What do you mean the back?
The backing plate, is that aesthetics? Is that mechanics?
No, it's to give me a lip that I can bolt onto the frame.
Okay.
That's all it is. Okay? That's to bolt it onto the frame, which is why you can do it in different positions, and also to give something for this.
So if you wanted to run this wet, what position would you be putting your classifier in?
Well, you wouldn't be classifying at all, but I would probably blow it straight down into an external classification. That way, once it gets out, it's out. You could also go this way or that way, but then you have the possibility of heavy stuff settling down and eventually creating a plug.
And that particular panel is the only place where there's a hole in your chamber here? How does
this work? One right here. This is the only hole in the chamber. Now, the reason you see 2 plates here is because originally this was 4 inches wide and I extended it to 6 inches. So in general, if you were to build a 6-inch one, it would look like this. Okay, what these are internal wear plates. If you look here, you will see the actual chamber does not get any wear. These things do. So that as they wear out, you can throw them away. They also have these bars welded on them. It's just regular. By the way, all this is mild steel except for the hard facing. So you have these bars, and what they do is they keep the violent abrasion away from the plate itself and away from the mounting bolt.
So they're sort of sacrificial pieces then?
Yeah, and these also are hard faced. By doing it this way, instead of having to hard face an area, all I do is hard face 2 lines. Okay?
And hard facing, yeah.
Okay, and so it makes it a lot easier to hard face. These bolt heads are protected well enough that they never wear out. Okay, and so you don't have to worry about it. On the other hand, these bolts that hold the wear plates onto the rotor, they do wear a lot. Okay?
Yeah, the one back there is a good example of that.
Yeah. Now, I put the nuts forward because nuts are cheaper than bolts. If you're going to wear out a hex and have to throw it away, I'd rather it be 40 cents rather than $1.90 or something like that. Okay? So that's what I do. I'll put brand new nuts. If you look down here, you'll see there's a couple new ones. And that's because while I was pulling them off, anytime when I pull it off, the nut tries to stick inside a 12-point socket where I got to kind of work it a little bit. Okay, it's starting to get worn. I'll put new nuts here because they take the most wear. Once they wear a little bit, I'll put them up here. When these wear to the point where they're sticky, I throw them away, replace them with nuts from this outer rim.
Rotating.
Yeah, and so they migrate this way and then go bye-bye.
And I noticed that some of these plates actually have numbers written on them. What are those for?
Well, this is a rotor that spins at about 1500 RPM. And if everything doesn't weigh the same, you're going to have an imbalance which results in a lot of vibration. So what this is, this isn't the final weight, but it was a preliminary weight. When we got it hard-faced where it's like, okay, that's enough, then we take these 4 plates here, which are these, we weigh them, find out what the heaviest one is, and then add a little more hard facing to the other plates until you get the exact same weight. So that when we bolt all of these to this rotor, it is balanced. If it's significantly imbalanced, you can break the bearing.
Yeah. If it is significantly imbalanced, it gets very loud and clangy, and then these big heavy bearings right here break. Right at the top, actually, is where they fractured last time, right where those little nipple type things are. They just split.
Anyhow, the other thing that can happen, you can break the shaft. Vibration is not a good thing, excessive vibration. These plates here are welded to the shaft here. That is the only place that the shaft has any welding at all. If you were to weld these plates to the shaft, in the normal way you'd generally think of doing it, you create a weak spot and you'll get a crack starting to propagate through the shaft back here. So the shaft is continuous, it's just pressed in between these plates, and the welding is on the plates themselves just to hold this box around the shaft. Then I plug weld the end of the shaft to the rotor, and voila. One of our other viewers has taken set screws and put them here, you know, just drill holes and then weld nuts up there, and he says it works just fine. I think that would be nice because it would allow you to replace the rotor without replacing the shaft itself, but this is what I got, and until I need to replace it, I'll just go ahead and keep using it. These braces here are because these welds, they create an embrittlement where this steel is molten and then it cools quickly, it gets a little brittle. And without these braces, these things flex enough that it starts to crack, and within a few hours, one of these plates will crack far enough that it's starting to come apart. It'll hit the housing and make a huge amount of noise.
Very bad things could happen.
Yeah. Now there's about a 1/2 inch of clearance here. What we've had happen so far is when a bearing breaks or this plug weld failed once, the rotor quickly touches either the back housing or the front cover and makes a huge amount of noise, and you get it shut down before anything horrible happens.
And you can see, I think, on the back here,
Well, that's the cover.
down the bottom on the cover, you can see the scrape marks from when that happened that one time.
Nah, not anymore. This is where from.
Yeah, well,
this
there's
is where
still
the material
circular
feed is.
Yeah, there are still circular scrape marks there.
Well,
but-
there's lots of circular stuff, but I think they're kind of polished off at this point. Anyhow, so the wear bars and the hard facing here protect the housing. The wear plates and the hard facing here protect the rotor. Do not run it through the hard facing, because what will happen is part of it will wear through quicker than others. Then you get wear on your rotor. Now you got an imbalance problem, and it's going to do nothing but get worse. What I've done here, you see these steel washers? This rotor was a little imbalanced because of wear, so those rotors balance it out. Those washers there balance out the rotor, assuming the plates are all the same, which they are now.
And getting the rotor balanced is critical to good function, correct?
Well, you don't want vibration. Imbalance equals vibration. Vibration equals wear and destruction.
And how did you choose the position for your motor? What's up with the motor and the pulley system here?
That's just so that I can get the pulley on the motor lined up with the pulley on the shaft. And, you know, this right here is a clutch system where the an idler pulley comes down and tensions the belt. Without being able to clutch it out, it's kind of hard to start because you got a lot of mass for your little engine to do. And we just bring this down, and this is an adjustable tensioner depending on how far you hook it down the chain. So let's go ahead and bolt all these up, and then I'll put the cover plate on and you'll see how that works. Okay, so we've now got the wear plates in place, and this is a good time to take off the belt to allow it to spin freely. See how it pretty much just keeps going and going without a real preference. Get it horizontal like this, press down, horizontal, press down. See, this side is a little bit heavier, but it's not too bad. By the way, these are all balanced within a gram, the wear plates.
We found out that level of precision was pretty important.
Yeah, that's pretty good. Now, since we have taken and welded stuff to the outside edges of these, you also want to be sure that you haven't got a glop or something that's going to hit. So you just take something like that, go across the housing. Doesn't hurt to do vertical, although it shouldn't matter. That's when you're aligning the bearings. But anyhow, we got our clearances. Now, I got one bolt here on this side. See, these mounting nuts are way back from the edge. That works out better in the long run because it's easier to hit them. You got a lot more play with the bolts. All the bolts have anti-seize on them. Ask me how I know you need it. This cover here has a notch right there. And the reason is it's about 25 pounds or something. By putting that notch right there, putting this nut, or this bolt rather, through there. I really got the notch just a little bit wrong. I just put it on there. Come on. Okay. Now this would be, if all you needed was to inspect it, you'd remove those 3 bolts, swing it out of the way, put that one partially in, and that gives you a rest. You gotta pull this one out. Also, these holes are a little bit bigger than 1/2 inch, so that it's easier to line things up. This plate, it can move around quite a lot. It makes no difference. So it might as well have slightly larger holes.
And if anyone's curious about this one corner, that corner is painted with black chalkboard paint, so that you can keep tally on what you have run through the crusher.
Now you will notice a lot of other crusher designs have a bearing right here. That does make the shaft a lot stronger, but it also means to take this off, you got to cut loose of that bearing. So I kind of prefer this system, although if I was to build this from scratch the same size, I'd use a heavier shaft and a wider frame so I got more support between the bearings. But it seems to have worked pretty well. Now we're ready to go, and we're gonna kick some ass tomorrow. Right now it's clouding up. We got a few other things we have to accomplish today, so we're not going to start crushing, but happy prospecting and keep it safe out there.